how about the other, like pre-calculus, calculus? Do we need this in our future work and life?
Okay, if I understood the question is, do you need some of these elementary concepts for success in life? Did I understand it right? Is that? You need, my answer to that is yes, and in the following fashion. The more you move up, in the ladder of mathematics, the more options that will be available to you. So you may not be able to predict it right now. You may say, oh, I only need algebra 2. That's it. I'll just take algebra. I can make change at the grocery store. I can pay my bills. That's fine. Well, okay, you make that call, then you've ruled out a whole slice of other activities that you potentially could get into. And mathematics is, by and large, the language of science, the language of engineering, the language of most of the sophisticated activities that are going on in the world today. So my encouragement to you is don't pull up short. Don't say, well, okay, I got enough math now that I can do my day-to-day things. It might be true, but you don't know what's coming along tomorrow, and the next day, and the next day. And if you cut off that math knowledge, you just aren't going to be a player in those areas. It just won't happen. Almost every area that I can think of now, and I've been involved with pharmaceutical companies, I've been involved with polling companies, I've been involved in automotive companies. Most of the interesting, exciting things that are going on depend on math or statistics or both. And when you cut yourself off, you just eliminate that from your future possibilities. So my encouragement is, don't quit early. Don't quit early. You don't know what's on the other side. I clearly didn't know when I was in college, and frankly, I didn't know until I got to the workplace. But I had a background where doors of opportunity, at least fortunately, opened for me, and I could participate in exciting problems. So I don't know if I've answered your question directly, but that's my feeling on the topic. Yes, ma'am.
Hi, Mr. McDonald. I have another question.
Fine.
Like, what is the meaning of math for you in your entire life?
What is the meaning of math?
In your entire life. For your entire life.
Oh, what is the meaning for me? Well, on a personal and a professional level, it was everything to me. I thoroughly enjoy mathematics. I enjoyed my career. My career has not been work for me. My career has been just fun. I mean, I really enjoyed working on the problems that I got involved in. The beauty of math and statistics is that it cuts across all disciplines. So I happen to have a background in math and statistics, but I worked on engineering problems, manufacturing problems, survey problems, lawsuit problems, which involved analysis of statistical data. And I felt really blessed because every problem that the company faced, by and large, mathematics came into play, and we were able to contribute to those problems. So I don't know, again, if I've answered your question, but I think on a personal level and a career level, math and math sciences have been really enjoyable. Now, that doesn't mean that all the classes I took that were enjoyable. Yes, ma'am.
Why would we need people doing math?
Oh, because I get that question a lot. I teach at college now, and I probably get that question at least every semester from several students. Why should I learn math? Because the computer does everything today. The reason is math is not just doing calculations. The computer does that. I'll grant you that. The mindset of a mathematician eventually becomes a logical mindset. You bring to the problem, you bring to the world, you bring to the challenge a logic and a sequence of reasoning that isn't captured by a computer program, by and large. The computer program, by and large, becomes a tool that you use, but you still need to bring the logic to the problem, just like I did in this decision problem. I can write a computer program and get all that arithmetic very quickly. It'll generate the graphs, it'll generate the plots, it'll do all of that. But setting it up, structuring it, that is one of the huge assets of a mathematical mind. It's being able to do that. Let me give you an example. Many of you may have heard that you can make a lot. Well, you were the money guy, right? Okay. Well, that's good. That's true. If you go to work on Wall Street with a mathematics degree of a certain type, you will be very well compensated. At least you have for the last 10 or 12 years. The reason is MIT had two professors, Black and Scholes, that developed a mathematical system for evaluating what's called financial derivatives. Mathematicians understood those mathematical equations. They're differential equations. You probably haven't had that yet, but it'll come after calculus. Mathematicians understood those equations, wrote computer programs, and went off to Wall Street. And they were able to evaluate the value of mathematical derivatives. So if they saw the stock market overvalued a derivative, they would sell it short. If they found out that it undervalued a derivative, they'd sell it long. Terrific. People got filthy rich in a very short period of time. One of the projects that I got involved with at General Motors was how much should we invest in our manufacturing plants that were flexible. That is, should we pay a premium to put in robots and automated equipment that I could reprogram and make different type vehicles? It costs more to do that. And fortunately, I had two PhDs, one from MIT, one from University of Georgia, that understood the mathematical underpinnings of the financial derivative. The beauty of mathematics, they were able to abstract from that application, bring it over to this investment in manufacturing facilities, apply the same models with different definitions, and provide a mechanism for us to decide how much should we invest in equipment in a new plant if we were going to put flexibility in that plant. The same models, the same equations, different definitions of the variables worked magnificently well. The mathematical mind was essential. It wasn't the computer program. It was the ability to abstract from one application, bring it over to another one, see how it would apply, and then make the analysis, probably using computer programs. So that mathematical mind is a beautiful thing in terms of its logic, its ability to abstract, its ability to take concepts from one area and apply them to another area. I don't think you get that in other disciplines, at least not as much. Other disciplines are primarily discipline-specific. Math and statistics cuts across all kinds of disciplines: medical, manufacturing, engineering, social sciences, so forth. So my encouragement again is don't cut yourself short on the mathematics side. It will open doors to you that without the mathematical underpinnings, you just simply won't be a player.
Yes, sir.
So in your States, most of high school encourage suggest students to take the great classes of computer class instead of the statistics or economics. But which one in reality is more functional or effective?
The question is, well, the short answer is all of it. Now, I spent quite a bit of time at high schools number of years ago giving talks about what is mathematics and how to use it. Here's my feeling on it. Many high schools offer pre-calc and calculus. That's good, but it's only good if you understand what you're going through. Now, at the college level where I am now, I get quite a few students that come into college and they have a wonderful high school transcript. They have pre-calc and calculus, maybe AP calculus. But frankly, they didn't understand it when they took it. They got a grade, looks good on the transcript. Now they come to college and they don't understand it and they start to take a more advanced course. And it's a disaster. So I think calculus unquestionably is the building block for math. It's the transition from arithmetic to mathematics. And no matter if you're in science or engineering or even medical science now, biological sciences, you need that, but you need to understand it. You really need to know it. All right, now having said that, many high schools now are pushing statistics into their curriculum. It's been recommended by the National Academy of Science. I've been on government panels that have looked at this worldwide. Many high school students are being exposed to statistics because it's so pervasive in your life. I mean, think about it. Turn on your television when you go home now. What are you going to see? Oh, there's a poll. There's a new poll out. President Obama now has a 45% portion of potential voters, and Governor Romney has 42%, or whatever. You're exposed to this statistical thinking every day. And so just to be a good, critical consumer of information, you need to know statistics. And I do think you ought to get a shot of it in high school. Many high schools that I have visited, they build statistical into their science program. So in their chemistry lab and physics lab, they always do experiments and report them statistically. Most of them use these TI-83, TI-84 calculators to put the data and do some basic statistical descriptions and testing. Some schools have formal courses. I understand you do here. And so that's great. So I think those are very key building blocks. But the important thing at your level is understanding.